Hi, my name is Muhammad Azwan bin Hamzah. My metric number is 2024912491, and I'll be doing an experiment about how salts make ice stay longer. In front of me, there was 2 plastic cups and a bottle of ice and a bag of salt. I will put same amount of ice in both plastic cups, and 1 plastic cup I will add salt in it to see how long it takes the ice to melt. The duration is 10 minutes to see how the effect of the ice. And I will put the salt in the cup that will have rubber bands on it. And we will leave it in the room temperature for 10 minutes. As a result of the 10 minutes, the cup of the ice that contains salt tends to melt faster than the cup of ice that did not contain salt. The reason why the cup of ice that contains salt tends to melt faster is because table salt is known as sodium chloride, or NaCl, is a soluble salt. Since salt is an ionic compound and soluble in water, it forms attraction with polar water molecules. Anions are attracted to the hydrogens in water, while cations are attracted to the oxygen. As a result, the rate at which water molecules attach to one another is decreased, mainly because the concentration of water molecules in the liquid is lower. This is also because of the orientation of water molecules around the ions. Thus, adding a salt lowers the melting point and freezing point. How melting point and freezing point works. Ice absorbs energy or heat from the environment to break the hydrogen bonds that make it a solid, allowing it to turn into a liquid. In contrast, water releases energy, which is heat, when it solidifies into ice. Melting is an endothermic process, while freezing is an exothermic process. At the freezing point, these two processes are at equilibrium, so the energy absorbed by water freezing equals the energy released by ice melting. But when you add salt, you lower the freezing point of the water. Ice melts into water, absorbing heat, but does not refreeze into ice and release heat. So the temperature drops. How does salt lower the freezing point? Salt, or NaCl, sodium chloride, dissolve in water to form its ion, Na plus and Cl minus. The ion particles get between the water molecules and make it harder for them to align to crystallize into ice. This means the temperature has to be colder for the liquid to freeze. The ice becomes colder due to thermodynamic principles. Melting ice is an endothermic process, meaning it needs energy to transform the solid into a liquid. Therefore, the ice will lose energy while breaking those internal bonds. Another application of this when we put salt in water to make it boil. A normal boiling point of distilled water is 100 degrees Celsius. Presence of soluble salts increase the boiling point of water to 102 degrees Celsius, according to many research. Because salt is non-volatile solute, which is responsible for boiling point elevations, because sodium chloride dissociates into sodium and chlorine ions. These charged particles alter the intermolecular forces between water molecules and also induce ion-to-ion dipole interactions, which is more stronger than hydrogen bond and hence leads to the elevation of boiling point.